Hi there, I'm Tim Wong with NVIDIA Automotive Group. I handle technical marketing for autonomous vehicles. We're here today at CES. I'm going to show you a little bit of things we're showing here. So what you can see here is a Tesla Model S. This is a brand spanking new car picked up at the factory last week. And what's interesting is, starting in late October, every Model S, every Model X, and the upcoming Model 3 has an NVIDIA AI car computer inside. They upgraded the sensor suite as well, so there's still a radar sensor in the front bumper. As you can see, there are 3 cameras above the rear mirror. That's a very narrow camera for very far distances, a wide camera to see objects in front of the car, and a very wide camera for help with parking. Come with me. In addition, you'll see on either side there's a camera that faces backwards, and that's essentially duplicating what humans use the side mirror for, so as I'm passing or changing lanes I can see what's on the side of the car. Right here you have a very hard to see camera, but that camera is pointed out toward the corners, and the reason you need that is for high-speed cross traffic. If someone's about to blow a light at 90 miles an hour, I would like to see it before it happens so I can stop the car. So that's what that's for. And then above the license plate in the back, there is a camera facing backwards. In addition, there are 12 ultrasonic sensors, sonar sensors all around the car. So the 12 ultrasonic sensors, the 8 cameras, and the radar is Tesla's sensor suite that they feel is and it all comes into Drive PX, our AI car computer, to autonomously drive the car, as well as provide driver assistance. So this is how Tesla can ensure the car is safe, that it actually knows what's around it at all times. It can track objects, it can understand objects, it can understand, essentially have 360-degree situational awareness all around the car. In addition, we have 2 video walls that we are showing. First is AI Copilot. The purpose there is that when you have an autonomous system in the car, if you are driving the car, the autonomous system is still running. It's not controlling anything, but it's still keeping its situational awareness of everything around the car. It's still tracking things, and we actually have a camera facing the driver for driver monitoring. And the reason for that is today, when I tailgate a car, which probably isn't a good thing to do, but I do it anyway, my pre-collision warning yells at me all the time, to the point where now it's yelling at me so much, I ignore it. And so if it really were to happen, I would question whether it was real or not, and that's a split second. So what happens is when you warn someone too many times, it starts to be noise. And so what we're trying to do is do meaningful warnings. The driver-facing camera, if I see that you're looking off to the left and a pedestrian's about to enter a crosswalk on the right, looking at their phone, so they're not looking at anything going on, you're clearly about to hit them. The car understands what's around it and that's about to happen. It also knows that you're not looking the right direction, so it'll give you a warning. You know, pedestrian on the right coming up, and you should take notice. And that way you reduce the number of warnings to the ones that actually are meaningful. And so that's the whole point of our AI Copilot, is that it becomes a companion or a guardian angel or whatever you want to call it, where they are helping you drive. We also did facial recognition, and this isn't facial recognition for security, this is facial recognition for convenience. I right now have 2 seat memory controls, and it'll do my mirrors, but the point here is that, I don't want to have to program a button. It will just recognize that who I am, that I'm often driving the car, and it knows what my settings are for my radio stations, for the seat controls, whether I have the seat heater on and off, and basically all the things I typically do to set up to drive the car. When my daughter gets in, it'll change to her. When my wife gets in, it changes to her. But the whole point is I can do a multi-user car environment with facial recognition. Lastly, another AI that's facing the driver is, we call it LipNet and lip reading. And there was recently a lot of work done on lip reading neural networks, and what they found was the best human lip reader could do about 52% accuracy. When they trained all this data and took basically lip reading and trained a neural network, they got to 92% accuracy. The beautiful thing about that is that if you speak with an accent, if you speak, so you're not a native language speaker, if you're sick, your voice sounds different, and so the natural language speech recognition has trouble with it. As well as if it's a noisy environment. Say the windows are down, it's convertible, your kids are crying in the back, there's just honking horns. I mean, the problem is a car is not a quiet environment, and most speech recognition does really well when it's deathly quiet, but that's not a car. So you do that, you do your speech recognition still, but in addition you add lip reading. And the two together give very high percent accuracy that the car will understand what you're trying to tell it. So that's the whole point between AI Copilot, is that I want to have the car understand what I say. I want to have the car help me when I'm not paying attention in the right place. The video on the left, on the right side, is our BB-8 car. That's our BB-8 AI car, and what we've done is we've taken a car, we've set it up with cameras. There's 6 cameras. There's a front camera, 2 high-speed corner cameras, 2 rear cameras, and a backwards camera, and they basically are tracking objects all around the car. And what we're showing in this video is you need multiple AIs running simultaneously to drive the car safely. There's a natural language speech recognition, so I get in the car and I say, please take me to Starbucks in San Mateo. I leave my Redwood City house and the car starts driving on its own. The first thing it comes to is a stop sign. It recognizes it's a stop sign, it understands to stop, look for cross traffic, make sure it's clear, and then go. Then it comes onto a traffic light. Traffic light's green. It actually understands the difference between green and red and the fact that it is a traffic light. Traffic light's green, so it just goes without stopping. Then it has to merge onto a freeway. It actually has to go on the freeway. You actually have to do a roundabout, so it slows down for this turn, but then it's an uphill ramp, so it starts accelerating because it knows by the time it gets to the top of the ramp, it needs to be at speed. It gets to speed, it merges over, so it changes lane to get on the freeway. It actually has to change freeways, so you see it change again to the exit lane. It'll basically turn around, change to the next freeway, do the same thing where it merges in with traffic, exit off, and toward the end of the video, what happens is the car, the driver says disengage autopilot, but if he hadn't have said that, because there's no high-res map data at the exit of the freeway, the car can't drive safely anymore because it doesn't have that additional data. So the car would have handed off control to you. It would say, in 1 mile you need to take control, in a half mile you need to take control, please take control now, and then you have to confirm, I'm taking control of the car, and then you start driving again. But that is end-to-end driving. The other video we're showing is Lombard Street in San Francisco, as I believe they call it the curviest road in the US. It's a very tight road to do. Entertainingly, the driver, I guess driver in quotes, is doing selfies of himself because the car is doing a great job driving autonomously down Lombard Street. So again, it's showing a technology demonstration that the car can handle these very tight turns, and the driver clearly is not paying attention because he's doing selfies. But it's showing the capability. And then lastly, we have a course outside in the Gold Lot where we have a track, and it's a very simple track, but at some point we do dirt, we do grass, we do rocks, and so we make the track very varied because road conditions vary. You don't always have a clearly marked road. And then we also put a detour, a construction detour, where we actually reroute the car, and the car recognizes that there's a construction detour and it reroutes itself. So these are all the different AIs we believe you need to have in the car to drive safely, and this is what we're showing at CES in Las Vegas.